Welcome in, my party people, to our class on proportions and proportions word problems. In today's class, this is part 1 of 2. So today is more so the introduction to handling proportions. But as we saw before I started the recording, we talked about how proportions make us feel, especially those word problems and setting everything up correctly. So this is today's game plan to help us go, like I said, from confusion to confidence. Step 1. When it comes to proportions, we have to know how to solve them, flat out. We cannot pretend that we can just think that setting things up correctly is all we need to do. There's a way to solve proportions that I think we've all been around. For example, in the chat box, have we ever come across the idea of cross-multiplying and dividing? Who's been there before? Who's heard that before? Oh, that's a lot of folks, right? That's a lot of people right there. Now, let's go ahead and ask ourselves the following question. Who here knows more techniques, confident techniques, other than cross-multiplying and dividing? Who here knows more than just cross-multiplying and dividing? And confidently, and be honest. Brianna, not me. A couple of dots, not sure, not me. Got a couple folks in my program saying yes. The bow tie method. We'll see what that looks like. It might be what we're doing. It might sound differently, but it might be it. Right on. All right. So number 1, we're going to be working on, again, solving proportions. One of the main ways is going to be cross multiplication and division. Another great way is going to be understanding fractions and simplifying. And then number 3, we're also going to go over the convenient method, where if the numbers are lining up conveniently, hey, you can take half the time off that it takes to solve. So we're going to go over that first, solving proportions straight up. Number 2, after we get into solving proportions, we're going to be learning how to compare items correctly. So this is where we start getting into the main idea of proportions, because remember, when it comes to any topic in arithmetic reasoning or word problems, what you're going to learn is that once you identify the concept, you can identify the strategy. One more time. Once you can identify the concept, you can identify the strategy. So with that said, we're going to be solving them first, setting them up second, and then number 3, we're going to set them up and then solve them all together with some timed practice. And like I said, today's part 1 of 2. In the next lesson, we're kicking it up a notch with more time practice, test level questions. That way you can really sharpen yourself up. So with that said, my party people, let's get into it with our first set of notes. So we have first, again, solving proportions, and we have 3 main methods. And what I want y'all to do, all I want y'all to do is write down these 3 notes. And in the next couple of slides, we'll be talking about solving those proportions with those techniques. So with that said, my party people, here's a timer on the screen coming up right there. And I'm going to go ahead and give us a full 2 minutes. That way there's more than enough time to get this written down. Timer started. And when you're ready to move forward, simply type ready in the chat box. And then at the 2-minute mark at the end, we'll get started with the examples. Still got another minute left here. And again, just worry about writing everything down, and we'll casually practice it one by one. You're good. All right, my party people, and that is time. Are we good to move forward here? It's just 3 main notes. Number 1, just solving proportion methods here. So number 1 is just going to be that typical common cross multiplication and division. Steps 2 and 3 are not steps. They're more like methods, like I said. And number 2 is going to be looking to simplify first. You can simplify vertically or horizontally. Let me be very clear about that. Vertically or horizontally, not diagonally. That's the cross multiplication method. No simplifying there. And then number 3, this is the convenient situation method that I was alluding to earlier, where if you find a convenient comparison where one numerator is a multiple of the other or one denominator is a multiple of the other, you can just compare the same things in the same way to get that done. Now, enough talking. Let's actually go ahead and see these examples play out. So in this first example, we're going to be solving for x here. And on the left side, we have a fraction 3 over 9. And on the right side, we have x over 27. Now, here's what I'm going to do first. And this is one of the reasons why I love teaching, because I'm going to play off of what you already know, and then I'm going to help you discover how we can do things just a little better. Because everybody, let me make the point here. Let me make it very clear. Everybody, is the test that we are preparing for, is it timed? It absolutely is, right? It's absolutely timed. So the question begs, like, are we going to have all day? Absolutely not. So what's the point? The point is we should aim to not only do things correctly and confidently, but quickly as well. So we have to be correct, we have to be confident, and we have to be quick. My party people, do you understand why we're going to go through these different techniques? Perfect. All right, sounds good. So let's go ahead and get that W one at a time, unless you're the Chiefs. So here we are. 3 over 9 equals X over 27. So let's go over number 1, cross multiplication and division. This is what that looks like. We're going to go ahead and cross multiply the 9 with the X. My party people, 9 multiplied by X. How do we write that again? 9X, that's right. So 9 times X, that's going to give us 9X. And then if we cross multiply over here, we have 3 times 27. Now, does anybody know what that is off the top of their head? 3 times 27? I saw one person give it, but then I have a couple others saying no, a couple more people coming out with the answer. But given the amount of time it took, I'm pretty sure we probably calculated by hand. So that's fine, right? Again, I'm just trying to make a point. It's not the easiest thing in the world to do 3 times 27 right there at the top of your head. But let's go ahead and do it here on the side. We have 27 multiplied by 3, and then let's get it and do it. So 7 times 3, that's going to give us 21, and we'll carry that 2. Then we have 2 times 3, that's going to give us 6, carry that 2, and that's going to give us 8. So we have 9x equals 81. Then from here, everybody, what was that technique again? Cross, multiply, and what? Yeah, cross, multiply, and divide. That's right. So step 2 is going to be divide. Right here, divide by 9, divide by 9. And so that's going to cancel out on the left side. And on the right side, everybody, 81 divided by 9 is going to give us what? How many times is 9 going to 81? Correct, 9. Because 9 times 9 is 81. So everybody, is that a good refresher for you? Cross, multiply, and divide. To solve any proportion, this will always work. Cross, multiply, and then once you have it, divide both sides by that number in front of the X, and we're good, right? Now, let's just explore and talk about why this may not be the only technique that you should commit to. Everybody, let's talk about that 27 times 3. Can we all agree that although we can do that pretty quickly, can we all agree that the numbers can get much bigger than that? Yeah, the numbers can get much bigger. So what's going to happen if we're constantly cross multiplying and dividing, constantly running into big numbers or numbers that we don't know really how to divide by, right? It can be time consuming. Excellently said. So let's go ahead and explore techniques 2 and 3. Let me go ahead and show you number 2. Let me move this over here. Let me split this down the seam right there. Now let's talk about number 2. Technique number 2, like we talked about, it's simplifying vertically or horizontally before you cross multiply and divide. Let's go ahead, zoom on in just a little bit. Everybody, what do we notice about 3 over 9? What is that S word that I just said 5 seconds ago that we can do to this fraction? Yes, the word is simplify. We can simplify this fraction. Now, just as a quick refresher on how to simplify, what we are doing is finding the number, the biggest number, that can be divided into both the numerator and the denominator. What's that number going to be with 3 and 9, my party people? Correct. That number is going to be 3. We can divide the 3 out of both the numerator and the denominator. So just simplifying vertically is what we're doing. And so once we do that, everybody, 3 divided by 3, that's going to be what? Correct? That's going to be 1. So I'll write the 1 right there. And then the follow-up, 9 divided by 3 is going to give us, correct, 9 divided by 3, that'll give us 3. So my party people, check this out. once we simplify, what do we notice about the numbers? Did this proportion, if we wanted to cross multiply and divide, did this proportion just get easier or harder? Yeah, we just made the numbers smaller, making it easier, right? We just made it easier. Notice that simplifying right here takes less time than figuring out what 27 multiplied by 3 is. It takes much less time to simplify that really quickly. And once we do that, guess what, everybody? Let's cross multiply and divide. Look at this. Cross multiply, let's do this in red. 3 times x. Okay, that's 3x. 1 times 27. Oh, Lord, that's the hardest thing I'll do all day. 27. And then once we're here, now we're just going to divide both sides by 3 and call it a day. And we're good. Jenna, hold on to that question. I'm going to repeat that in a moment. Great question. So, divide by 3 on both sides. Look at that. X equals 27 divided by 3, which is what, my party people? Yeah, that's going to be 9. Everybody, is that the same answer that we got before? Yes, it is. Correct. Yes, it is. X equals 9. Both ways that we did it. Now, Jenna had a great question here in the chat box. Jenna's question was, what if we're not able to simplify? What if we are not able to simplify? Everybody, especially those of you who have been to my classes before, what do I always say? If we realize that we don't have a convenient situation and we can't simplify, what do we resort to? All reliable. What's it going to be? Let's see. Who knows? What are we going to default to? Exactly, Shannon. We're going to default to cross multiplying and dividing. Cross multiplication and division is always going to work. Always. The reason I'm teaching you these other techniques, like simplifying first and then next up the convenient situation, the reason I'm teaching these is because those are, if you notice the convenience, if you notice the ability to make the problem easier before you solve it, take that opportunity. You're saving time because you're taking a standardized test and you're under a timer. I got you, Jenna. Everybody else, does that make sense to you as well? We want to look for these convenient situations, but if you don't have it, go straight to cross multiplying and dividing. Don't waste time. Just get it done. Perfect. Perfect, perfect, perfect. So with that, just as a review one more time before I go over that third technique, again, we can simplify either the numerator-denominator relationship on the left or the right side. You can just pick one, you're fine. Or you can simplify horizontally if you'd like to as well. So technically, we could have chosen to divide both the 9 and 27 by 9 if we wanted to. And so simplifying does not actually change the answer. It doesn't. Simplifying is just rewriting the fraction in a smaller or different way. That's it. It doesn't actually change the value. So with that, let me go ahead and take this, move it over to the right. And now I want to show you technique number 3. This one's honestly one of my favorites, simply because there are quite a few questions that you can get done on your practice test and Real Deal this way. So my party people, here's what we're going to do. First, I'm going to just refresh with you the idea of how proportions work. Proportions are comparisons. You're basically saying this fraction is the same as or equal to this fraction. So there's a comparative relationship that we can take advantage of. Here's what that looks like so I can make your life real easy. Everybody help me out real quick. If I wanted to go from 9 to 27, what's the relationship? What's the comparative relationship? Not addition, subtraction. I'm talking specifically multiplication and division. One more time. Not addition and subtraction, multiplication and division specifically. What is the relationship going from 9 over to 27? What do you multiply or divide 9 by to get there? Be specific with the operation. I see the number. I see y'all say 3. But what operation? Yeah, that's going to be multiplication. To go from 9 to 27. Again, the order matters. That's going to come back in a moment here. The order absolutely matters. To go from 9 to 27, that relationship is times 3. Now, notice that we went from left to right. You're going to hear me say the following a couple of times today. And by a couple, I mean probably, what was the score last night? 41. So probably 41 times. Okay. So here, From the left side to the right side, it's a times 3 relationship. That's what's going to happen up top. From the left side to the right side, the relationship is times 3. Everybody help me out real quick. What is 3 times 3? Oh, that's going to be 9. Look at that. Super easy. Barely an inconvenience. That is the answer. So that's that comparative method that I was talking about. If you notice that you can compare one way to the other, whether it's vertically or horizontally, that same comparison goes on the opposite side. So let me go ahead and break it down for us just one more time, because I really want to make sure this one makes sense. Because when the convenient situation is there, you can save a ton of time. One more time. If the convenient comparison is there, you can save a ton of time. So here's what we did. I compared the left to the right because I was like, how can we get to x? We can get to x going from the 3 to the x, left to right, or bottom to top. And I'm going to show you the bottom to top as well. So here, 9 to 27, left to right, we notice that it's times 3. And so by rule, by law, if you're going left to right on the bottom times 3, you have to go left to right up top times 3. And that's how we know 3 times 3 being 9. And there's our answer. My party people, just to make sure I'm not crazy, is that the same answer that we got doing it every other way? Right on. So I'm glad we see that there's some convenience to this, right? And we're good. Now let me go ahead and show us, like I promised, the other way to do that convenient comparison. Let me just take all of this right over here. Let's just move it down. Perfect. Now let me go ahead and do a convenient comparison one more time. Let's go vertically. Let's see bottom to top. Like if we wanted to find a convenient way to go from 27 to x, look no further than over here. I want to go bottom to top. So let's see what the comparison is bottom to top. Everybody, quick question. Do we go with multiplication or division, and by what number? Again, starting from the bottom, going to the top, what operation and what number is it? Yeah, to go from 9 to 3, that's division. We're going to divide by 3. Now let me show you what this looks like. Divide by 3, bottom to top. If I notice that comparison on the left, from the bottom to the top, divide by 3, look at this. Everybody help me out because you know I'm bad at math. 27 from the bottom to the top. If I divide 27 by 3, what does that make x? Oh, look at that. X equals 9. This is almost like magic. Look at that. Look at that. And there we are. So before I continue, everybody, whether you agree with the techniques or not, can we acknowledge that these techniques work? Perfect. Perfect. Now I want to follow up on that and ask this very important question. Everybody, even if we don't agree with the technique or don't exactly see what's going on right now with this second and third techniques that I just showed you, remember, what is the technique that we can always default to if we're confused or anxious or nervous? What's the technique that we can always do if we don't notice the conveniences? What can we always do? Catherine, appreciate you. Cross, multiply, and divide. We can always do that no matter what. No matter what. So you don't have to waste time, hoping and wishing for a convenient situation. If you don't see it, you don't see it. And just go ahead and cross, multiply, and divide, and you're fine. So with that said, I know some of us want to see more examples. Who's ready to see another example coming up? Hey, let's go. Love the excitement. Let's go ahead and get into the next one here. And don't worry, once we're done with all of these examples, I'll go back 5 seconds apiece to let you take a screenshot if you want to. For those of you in the program, this is recorded and you'll find it first thing tomorrow. So here we go. Let's take care of this one, everybody. Let's go ahead and cross multiply and divide. Let's just go ahead and do it. Cross multiply here. 10 times x, that's going to give us what, everybody? Quick in the chat box. 10 times x shows up as 10x. Right on. And then if we do 5 times 20, 5 times 20 is going to give us what? Correct. That's going to give us 100. So 5 times 20 is 100. And so now we have 10x equals 100. My party people, the last thing we do is divide both sides by that number in front of the variable. So we're going to divide both sides by 10. So everybody, 100 divided by 10, what's that going to give us? Correct, that's going to give us 10. So x equals 10 in this case. Now, who would agree if I said that that was pretty quick? You know, even with cross multiplying and dividing, that was pretty quick. Yeah, pretty straightforward, right? Good. I'm glad that we feel that way because we should feel that way. Now, let's consider those simplifying and convenient situations. Everybody, let me just show you what my thought process is when I try to look for those situations. Here's my thought process. Let me just go ahead and highlight the answer there, x. I'm trying to get to x. Now, I want to think about if I can come at the x horizontally or vertically. Let me use two different colors to make your life pretty easy here. I try to think of it like that. Can I find a way to go left to right to get to x or bottom to top to get to the x? And conveniently so, we can do that both ways in this specific problem. Again, you won't always have this convenient situation, but when you do, take advantage of it. Because here, what did I notice? I noticed that if I go from left to right on the bottom, let me go ahead and just copy that over here. If I went from left to right on the bottom, everybody, what operation and what number? Only use multiplication or division and then give me the number. Yeah, if I'm comparing from the 10 to the 20, that's a times 2 relationship. 10 times 2, that's 20. It's as easy as that. 10 times 2, that gives me 20. And because we know from the bottom, left to right is times 2, on the top, left to right is going to be times 2. Booyah. Everybody, what's 5 times 2? That's 10. Look at that. We get x equals 10 as our answer. Let me zoom on out to make sure I got it. Yes, we did. And yes, we did. So notice that if we are keeping an eye out for those convenient situations, we don't even have to multiply and then divide. We can do it in one shot. That's the point I'm trying to make. If you can notice these convenient situations, it is well within your interest to take advantage of that situation. Is this starting to make sense a little more than before, my party people? Let's go. Perfect. Perfect. And so, yep, I see the request to do the simplification method again. So I'll go ahead and do that with this one here. Let me move this over. And let's go ahead and do the simplification method here. So look, if I wanted to simplify first, you are more than welcome to. Everybody, 5 and 10. What can we divide into both 5 and 10 to simplify this fraction? Yeah, we can divide them both by 5. 2 is what you'll get when you divide the 10 by 5, but be very careful about how you say that, right? Because we don't want to get confused. So we can divide 5 out of both 5 and 10. So let me do that right there and divide right here. Let me go ahead, set up my fraction right over here. Still have that x over 20. But if I simplify this fraction, 5 divided by 5, everybody, what's that going to be? 1, correct. 10 divided by 5, that's going to be what? Correct, that's going to be 2. So we have the 1 over 2. And this makes life, again, a lot easier. And even if you want to do the comparison method, 2 times 10 does give you 20. 1 times 10 gets you that 10. Or you can just cross multiply and divide, finish things up. 2 times x, 1 times 20, that's just going to be 20. And then divide by 2 on both sides, and we are done. X equals 10, still just the same. So look at that. In just the past 5-10 minutes, we've been able to go through 3 very solid techniques to go ahead and solve proportions. Now, I'm going to keep pressing you on this because I want you to feel confident regardless of what happens. Everybody, what is the default strategy if you don't notice convenient situations? Yeah, default strategy is always cross, multiply, and divide. Again, once you get into that mode of practicing under a timer, trust yourself. If you don't see it, you don't see it. Cross, multiply, and divide, and you're good. So with that, let me allow you to take a quick screenshot of the first question if you'd like to. Like I said, give you 10 seconds here. Take a screenshot, take a picture, do whatever you want to do. 4, 3, 2, and 1. Feel free to take another screenshot of the one that we just did here. And 5, 4, 3, 2, and 1. Are we ready to move on to the next example problem for solving? All right, sounds good. Let's get it done here. So here's the next one. We got 2 over 7 equals 10 over x. It's going to switch up where the x is in this problem just a little bit. So we have 2 over 7 equals 10 over x. Let's just go straight up with the default situation. Let's just cross multiply and divide. Let's just see how quickly that can get done. So if I cross multiply 2 times x, 2x, then we have 7 times 10. Everybody, again, I'm bad at math. 7 times 10, that's going to give me what? Emma, appreciate you. That'll be 70. So now we have 2x equals 70. From here, like we know, old reliable tells us, cross multiply and then divide. So I'll divide both sides by that 2. And once I do that, I got to figure out what 70 divided by 2 is. So if I need to use some long division, I can perfectly lean on that, no problem. So let's go ahead and do that here. 2 going into 70. 2 goes into 7 3 times. 3 times 2 is 6, so I'll subtract the 6 and get 1 left over. And then from there, we drop the 0, so we have 2 going into 10. 2 goes into 10 5 times, and there is no remainder, meaning that 70 divided by 2 is a clean 35. So again, my party people, are we confident with cross multiplying and dividing? And also, do we notice the time we need to take to get it done? Do we acknowledge that we have to multiply and divide, and depending on the numbers, it can take a while? That's all I want you to realize. I'm not asking you to stroke my ego and agree with every technique I'm showing you and adopt it. I just want to help you naturally come to the conclusion that, yeah, I know what I can always do. And on top of that, if I want to do it faster, I can always think about X, Y, and Z. That's the point of this. So we have the answer, 35, and we did a good job. Now, if this was a real test and I wanted to make sure I got this done as quickly as possible, what I would do is this. I'm just going to zoom on in. I'm going to look at the proportion, and I'm going to compare the same things in the same way. I realize that I can go from 2 to 10 by multiplying by 5. And I can get my final answer done super quick because I can go from left to right, again, the same exact way, left to right, and multiply by 5. Everybody, what's 7 times 5? 35, and we're done. Look at that. Look at that. So that's how straightforward it can be if you know what you can look for. That's the advantage that you have. Does anybody feel excited about knowing this and they didn't know this before, but they're happy they do now? Right on. And I saw a great question here in the chat box. So a question was, how do I know whether I'm going left to right, right to left, up and down to up? How do I know, right? How do I know? So the rule of thumb that I go with is, hey, if I'm trying to get to the variable, what are my options? My options are coming from the left to the right or the top to the bottom. I noticed that if I go from top to bottom, on the other side, I can't really do that. 2 times a whole number, can't really get a whole number to multiply to 7. So I'm going to avoid that way because it's not clean. It's not a whole number. It's not pretty. It's not convenient. But if I go ahead and think about the other way, from the left to the right, let me see up top what that looks like. Oh, 2 to 10? That's times 5 all day. And so that's what I'll do right over here, times 5, and we get it done. So in short, to answer your question, how do we know which direction we're going? You always point at the variable you're solving for, and you ask yourself, okay, how can I get here? From, in this specific scenario, from the top to the bottom or the left to the right. If you notice a convenient comparison, go with it. If you don't notice a convenient comparison, cross multiplication and division is always going to be trustworthy. So let me know if that helps anybody else out, again, with the confidence there in that understanding. And Catherine, that's just going to be just comparison. So comparing the same things in the same way. Let me actually write that down for us so we can really feel rooted in this. So compare, this is the main idea again of today. Compare the same things in the same way. Right there. Compare the same things in the same way. So there we are, my party people. I'll go ahead and give us a good 10 seconds before we go into the next example to try to solve a proportion where we'll keep really applying this technique. And 4, 3, 2, and let's gracefully go over to the next one. All right, so here, I want to go ahead and show you first that comparing the same things in the same way method, because I really do believe it's worth learning. So let's zoom on in here. So again, remember, earlier we were asking, how do we know if we're going from left to right, right to left, up, down, up? How do we know? So the first thing I do is I lock in on the variable. That's the first thing I do. I lock in on the variable. The second thing I do is I say, how can I get here? Not diagonally. That's cross multiplication and division. Not diagonally, not diagonally. What I could do is I could attempt to go from the bottom to the top, or I could attempt to go from the right to the left. So notice it's about how you can get to that variable. That's what I'm looking at. So let me go ahead and do one at a time to see if I can find that convenient comparison. So let's go ahead and start with the purple. Let's do the vertical one. So this says if I can somehow find bottom to top on the right side, it'll be the same comparison on the left. Everybody, is there a comparison with multiplication or division from the bottom to the top on the right side over here? Is there something we can multiply or divide 20 by to get to that 4? Is there? What's it going to be? Y'all say yes. What's it going to be? Give me the operation and the number. I know y'all are excited just throwing 5 in there, but what do you mean 5? 5 large fries? Because I love Chick-fil-A. I can go for it right now. Come on, be specific. Be specific. Yeah, we can divide by 5. That's correct. So notice that from the bottom to the top, we can divide by 5. Now, if we go ahead and do that over here on the left side, everybody, what is 5 divided by 5 going to be? Oh, that's going to be 1. So we have an answer here of y equals 1. And we can get that done, seriously, by just looking at it if we know what to look for. Don't believe me? Let me go the other way. Let me go ahead and look at the blue over here, the right to left. Because remember, everybody, the rule for proportions is that you are comparing the same things in the same way. So, my party people, help me out. If I'm trying to figure out the right to left relationship, I can look over here, the right to left relationship. Everybody, what's the relationship going from 20 going over to 5? Again, be careful, be specific. Going from the 20 to the 5, not 5 to 20. We got to be careful here. The direction and the order matters. Yeah, I'm trying to go from the right to the answer here, the right to the left. So right to left, it's division of 4. Correct. Very good, everybody. If I divide by 4, that's how I go from 20 to 5. And so we will compare the same things in the same way. Divide by 4. Everybody, what's 4 divided by 4? Oh, hardest question of the day, right? Yeah, that's going to be 1. So the answer that we showed again, look at that. It is 1. Now, again, if all else fails, we can cross, multiply, and divide. If all else fails, we can cross, multiply, and divide without a problem. So we can go ahead and say y times 20. That's 20y. 5 times 4. Everybody, what's 5 times 4? Correct. That's going to be 20. And then once we cross multiply, we'll divide both sides. We'll go divide by 20 over here and over there. Cancels out on that left side, giving us 20 divided by 20, which is 1. So whatever way you put it, we'll get the same answer, regardless of how it goes, because we followed a technique. So my party people, who here feels like they have a slightly better understanding of solving proportions here? Right on. I definitely see the number increasing. And if anybody here is still feeling confused, don't worry. You know I got your back every step of the way. We still have another example to go with. So let's see if that'll make a little more sense here with this last example. And so let me actually answer that question there, Catherine. So there's 2 questions I'm going to answer. So number 1 from Catherine, You didn't know that you could divide from right to left. Yes. So remember that when we're doing comparisons with proportions, comparisons is always multiplicative or with division. So it's multiplication or division. Remember that multiplication and division, they're actually the same operation. Typically, you multiply to scale up, divide to scale down, but scaling is what you're doing. Multiplication and division, same operation. They're comparative or ratioed operations. Now, the second question that I saw here that I want to answer is from Grace. Grace asked, hey, what if you have a mixed fraction? Not going to happen when it comes to proportions. When it comes to proportions, you're not going to be shown a mixed number over here on the left and then an actual improper on the right. That's not going to happen unless they're really just trying everything they can to just screw with you and throw you off. But it's not the way that this test is being administered. So you shouldn't expect that. You're good. And then with that said, I'm glad I could answer that. All right, looks like I got the general questions there. Some other questions that I saw in the chat box have to do with memorization, and we're not here to memorize. It's always going to be dependent on what we see. So I did see the last request here to go ahead and do this problem with the simplification technique, and I'm more than happy to do that before we go to our last example. Not a problem at all. I got you. So let's go ahead and write this fraction and just repeat everything right over here. Y over 5, 4 over 20. Let's zoom on in. My party people, let's check this out. The second technique that I talked about is simplifying. Can any of these fractions be simplified? Can any of these? Yeah, they can. Which of these fractions can be simplified? The 4 over 20. Yeah, the 4 over 20 can be simplified. Let's try that out, everybody, because we can divide the 4 and the 20 both by 4. So let's see what that looks like if we try that out. I divide the 4 by 4 and the 20 by 4. So when we have that there, we'll still have the y over 5 on the left side, but on the right side, 4 divided by 4, that's going to give us 1, and 20 divided by 4, that's going to give us 5. So look at that. We've gotten this to be as simple as we can possibly get it. And so what does this mean? Well, if this fraction is equal to this fraction, and both of the bottoms are 5, then everybody, both of the tops, both of the numerators have to be what? If both of these are 5s on the bottom and this one is a 1, then both of the tops have to be 1. You can still cross multiply and divide if you want it to show that. Perfectly fine. Y times 5 is 5y. 5 times 1, that's just going to be 5. And if we divide both sides by 5 after we cross multiply, nice and easy, we have y equals 1. So no matter which way we cut it, boom, we're good to go because we can trust ourselves with a convenient method. But even if we still needed to cross multiply and divide, we're still gonna be good. So that's the thing. Who here likes the traditional cross multiplication and division? Who likes that way more than what I've been showing so far? And again, you're not gonna hurt my feelings. Be honest. That's the way we would like to do things here. Who prefers cross multiplication and division, the traditional way, over these convenient situations? That's a lot of folks. So here's what I'm going to say about that. If that's what you're most comfortable with, go with it. There's no shame. Again, remember, the point was showing you more than one way to do things so you can save time when the opportunity arises. If that opportunity isn't present for you, you're good. Cross multiply and divide, do your thing, and move on. You're all good. So I want to go ahead and try out one more example here, and I want to give us a minute to try to solve this example. Are y'all cool with being timed with a minute to try to solve this one? Perfect, sounds good. Let me go ahead and move the timer down to just 1 minute here, and let me place it right here on the screen at the bottom right. And here we go. 3, 2, and 1. Do not share your answer. Just type ready in the chat box when you're ready. Do not reveal your answer. Give it a shot. All right, time's up. Go ahead, put your answer in the chat box, my party people. If you have an answer, let me see it. You gotta, if you're gonna take a guess, go ahead and put a question mark next to that guess. You're good. Okay, timer's out of the way. Yeah, that was a lot of time, right? Okay, cool. That's good. If we feel like that was a long time, that's a good feeling because you know that you'll have that excess time when you see it on the test. So let's go ahead and get it done here. 3 over 4 equals 9 over t. So let's go ahead here. And just technique number 1, let's cross multiply and divide. Let's do that old faithful, old reliable. Here we go. 3 times t is going to give us 3t. Then we have 4 times 9. Help me out, everybody. Bad at math. 36. I appreciate y'all. Thank you. So we have 3t equals 36 after we cross multiplied. And after we cross multiply, we're going to divide by that number in front of the variable. So we're going to divide by 3. Here we are. So once we do that, that cancels out on the left side because multiplying and dividing by the same thing. Goodbye. So here we are. We have t equals 36 divided by 3, and that's going to be 12. So again, with cross multiplication and division, not that terrible. Not that terrible at all. But sometimes we can save time if we notice the convenience. So with that, if we go ahead and just take a look, we can find the convenient situations by trying to get to the variable. There's 2 options. We can try to come down from top to bottom from the 9, or we can try to come from left to right from the 4. Either way, we have to find the same comparison. So what does that mean? If I want to explore potentially coming from top to bottom, we have to see the same relationship over here. Everybody, is there a clean way to go from 3 to 4? Is there a clean way to go down from 3 to 4 for us using multiplication or division? Yeah, not quite. Not that easy. You can't see that number very straightforward. It's not going to be there for us, so we're fine. However, everybody, is there a convenient situation from left to right? Is there a convenient way to go from 3 to 9? Oh, yes, there is. Yes, there is, right? To go from 3 to 9, that's a times 3 relationship. I can multiply 3 by 3, and that's going to get us 9. So what this means is, again, the main idea here, compare the same things in the same way. If I go left to right times 3, on the top, it's going to be the same relationship on the bottom, times 3 from left to right. Everybody, what's 4 times 3? Help me out. Yeah, that's going to be 12. T equals 12. And we can get the answer, notice, without having to even write anything down. We can observe this and see, oh, left to right times 3. So I can multiply 4 times 3 to get to the variable. That's 12. And we can save ourselves a little bit of time. And there we go. How do we feel, everybody? Did I convince any more people here on that convenient comparison technique? Or are we pretty much, I would say, have our minds made up to what we like? There we go. Got scared, but I got it now. Good old traditional way, all reliable. I gotcha. No worries at all. So with that, I'm glad and I'm grateful that y'all are able to, at the very least, entertain the idea of getting better and getting faster. I know that as the idea becomes more comfortable for you, it'll be something that you will less avoid and more embrace. And that's what I'm going for by just inviting you to try things out. So with that said, that's it. We are done with the first part in terms of simply purely calculating proportions. So I have one quick pop quiz question before we move into the word problems. My party people, that question is this. If we can't simplify a fraction, if we can't do a convenient comparison, what do we always resort to quickly? Correct. Cross multiplication and division. Cross multiplication and division. If we don't notice a convenient situation in the first 5, 6, 7, 8 seconds, do not waste your time. Go for cross multiplication and division, and you're good. So let's move it over here. Let's keep having fun. Now let's start talking about word problems. So here's the big elephant in the room. Here's the big elephant. Who here feels a little nervous when it comes to really any type of word problem? Yeah, that's the boogeyman, right? That's the boogeyman for a lot of us. It's what's really holding us back when it comes to this specific test. I got you. I understand. Been doing this for quite a long time. So here's how I like to teach word problem concepts. And it's a very convenient way, not related to the convenience of calculating. But it's this. When it comes to proportions, here's our main idea. The main idea is compare the same things in the same way. If we can get this in our heads, compare the same things in the same way. I'm going to underline the most important parts here. Compare the same things in the same way. If we can commit to this and do this correctly, your setup will always be correct every single time. So I want everybody to take a good 20, 30 seconds, write this down, write this down, write this down. Compare the same things in the same way. Right there, big bold letters, top of your page, because I'm going to show you how every single word problem that we're about to do is going to follow this idea. Every single one. So type got it or write it in the chat box once you have this written down. And then we're going to get started on the first set of word problems. These are going to be with me. And then we are going to do timed practice as we continue along. Perfect. All right. Moving forward in 5, 4, 3, 2, and 1. So one more time, just repeating it again. Compare the same things in the same way. That is today's main idea for proportions. Here is our first word problem. All right, here we go, my party people. First things first, whenever we do a word problem, do y'all agree that the first thing I should do is read the entire problem from start to finish in a paint mixing project? The ratio, oh man, who just screamed at me in the chat box saying no? Who was that? Catherine. So what should I be doing here? What should I do with any word problem to make sure that I don't waste time? I see some of y'all saying RTQ. What does that stand for? Yeah, that stands for read the question. So my party people, this is what I mean. The first thing we should always do, proportions or any other word problem or even paragraph comprehension, whatever topic you are doing, read the question first. It's right here. How many units of red paint are needed? My party people, does that make things a little more clear? Like, even if you don't know the math that you have to do, isn't it good to know what you want to find at least? Yeah, like we should hope to understand what it is that we want to find so that way we can use the information to make a plan. But if what you're going to do is just read this from start to finish in a paint mixing project, the ratio of blue paint to red paint is 3 to 5. What does that mean? Oh, I have ADHD. I might need to read this sentence all over again. True story. I do have ADHD. Now, who here finds themselves reading a problem or sentence over and over again? Who finds themselves doing that? Especially when there are weird numbers or weird names or weird words. It's going to happen. The best way to stay focused is to start with the goal. How many units of red paint are needed? Boom, I understand the objective. The objective is blank units of red paint. Right there. You have identified what you want to find. Right there. Now, we also see in that same question sentence, because this is not where the sentence starts, it's right here. If there are 18 units of blue paint. So what they are telling us in that question sentence is that the number of units of red paint is going to be associated with the 18 units of blue paint. So I'm going to write that down over here. I'm going to say 18 units of blue, and that's going to be included with the whatever units of red. Is everybody here okay with me saying that? Because again, it appears in the same sentence. There are 18 units of blue. How many red? So I'm going to write that down. We have 18 units blue. I don't know how many red, but we're going to try to figure that out. We good on that? Sweet. Now, that's step one. I know I repeated myself quite a bit there, but I know it's going to be worth your betterment, so I'm cool with it. Now, number two, step two. Once we know what the question and the goal is, now we're going to move forward to writing down the information. We're going to understand what the numbers are. So here we go. In a paint mixing project, the ratio of blue paint to red paint is 3 to 5. Now, this is the first time that we've come across this today together, so I'm going to make sure to help you out. Everybody, there are two numbers here, 3 and 5. There were also two colors given, blue and red. My party people, Help me out real quick. Which of the colors is associated with the 3? Which of the colors is associated with the 3? Who knows? We say blue. Now, there's a couple of us that said red. The correct answer is going to be blue, but I'm not going to leave you hanging and just say, yeah, it's just going to be blue, move on. Nope, not how we're going to do things. Let's understand the reason why. Everybody, why is blue associated with 3 and red with the 5? Why is that? It's a certain word. It's 2 words. It's blank matters. Blank matters. Everybody, what's that word I'm trying to put in there? Starts with an O. The blank matters when it comes to ratios. Thank you, Alexa. Order matters. Order matters when it comes to listing a ratio out. Let me just go ahead and show you what I mean. We have blue paint to red paint. Blue paint, that's 3. Red paint is 5. It's the order in which it's stated is the order of the ratio. Does that make sense, everybody? To make things super easy, the order matters. So if they say blue to red, blue is the first number, red is the second one, right? Super straightforward. Super straightforward. Take some practice, but it's very straightforward. Yes, order matters always with ratios, Catherine. Absolutely. So here's what I'm going to do. We can write the ratio down here in purple. We can say 3 for the blue and then 5 for the red. So that way we can write the correct numbers in the right places. Now, here's where we're going to move forward and write the proportion out. Here's how I know I'm going to have a proper, correct proportion. Here's how I know. Pop quiz, everybody. What is the main idea for proportions? What did I just say one slide ago? Type it into the chat box. Every single person here, I do not care if you're trying to secretly watch this at work, calling somebody out right now. You know who you are. Type it into the chat box. What is the main idea here? Yes, compare the same things in the same way. Everybody go ahead and write it out. Compare the same things in the same way. Right there. There's our main idea. Compare the same things in the same way. Excellent. I love the participation today, everybody. Byron, I got to call you out. So here we go. Everybody take a look here. On the top, so this line right here, we're comparing blue to red. The first number is blue. The second number is red. Everybody, do we have the same comparison down here? The first number being blue, the second number representing red. Do we have the same comparison? Y'all tell me. Some folks are saying different. Don't look at the color of the words. I'm talking about the representation here. So my party people, let's go for it one more time here because I see what you're going for, but that's not quite correct. Everybody, this number 18, the first number here, 18, is represented by what color? The 18 is represented by what color? Blue. Okay, so our first number 18 is blue. Everybody, the first number down here, what is represented by it? What color? Correct, blue. So the first on top and the first on the bottom, that's blue. Now let's take a look at the second number. This number that we don't know yet is represented by what color? Red, correct. If we take a look at the second number down here, the 5, that's represented by what color? Also red. So everybody, do we notice that we have blue to red, blue to red? Do we see that we are comparing the same things, blue and red? But on top of that, this is the most important part, do we see that we're representing and comparing them in the same way? Blue is first, red is second. That's the big part there. That's how you know that you are going to set up a proper proportion and you're good. You're good. So let me go ahead and just put an X for the answer I'm looking for. And I'm just going to write the comparison down here. I'm going to compare blue to red. I'm going to do 18 over X because again, this is blue and this is red. And then I'm going to set it equal to the same comparison on the right side. Again, it's all about the same main idea. Compare the same things in the same way. Blue to red, I got to make sure then I got blue to red over here. And so I'll put the 3 for the blue right there. And then I got the 5 for the red on the bottom. That's how I know that I am good. Let me actually write that red with actual red so it makes even more sense. But do y'all see where I'm coming from? Do y'all see where I'm coming from here? When I say that we have to compare the same things in the same way, we got blue up top, red on the bottom. That's how I know that if I write this proportion out, before I even solve it, I know that once I'm actually going to, do the numbers and the calculating and all that good stuff, as long as I do the calculation correctly, I am guaranteeing myself to have the correct answer. So who here feels like that makes a lot of sense as it is so far? Right on. Perfect. So here's what I'm going to do next. I'm going to solve this with you. We're going to write down the correct answer, but then I have a couple of things that I want to say about this problem and all the word problems that we're going to do. And that's going to have to do with the question being, hey, coach, is this the only way that we can set it up? Answer to that is no. There's multiple ways that you can set it up, 4 different ways to be exact, and you'll be fine. As long as you compare the same things in the same way, you're fine. But let's go ahead and solve this, everybody. Let's zoom in. If we take a look at potentially comparing the same things in the same way, this is actually a super quick problem. Because everybody, take a look. Take a look. How can I go from 3 to 18? Yeah, I can go times 6. 3 times 6 is 18. So everybody, what's 5 times 6 going to be? If I do the same comparison right to left, 5 times 6, that's going to give me, 30. Look at that. Don't even need to calculate. Don't even need to go crazy with it. I can see that the answer here is 30. Now, if we wanted to cross multiply and divide, sure, let's go ahead and do it. I don't mind at all. At all. I got you. So here, let's cross multiply and show ourselves that we can still do it that way. X multiplied by 3 is 3x. And then on the other way, we have AT multiplied by 5. 18 multiplied by 5, got to take a little second to do that, but that's okay. 18 times 5, 8 times 5 is 40. 1 times 5 is 5, carry the 4 is 9. So we have 90. And then, everybody, we have to go ahead. That's a funny meme there. And at the end here, we're going to divide both sides by 3. So we're going to divide both sides by 3 here. Let me use a proper color. Let's use gray. So divide by 3. And once we do that, everybody, what's 90 divided by 3? Correct. That's going to be 30. X equals 30. And look at that. Still got the same correct answer, even with cross multiplying and dividing. But notice everybody, that there's 2 phases to this game. Phase 1, setting it up. Can we set the proportion up properly? Step 2, can we calculate properly? And that's going to be up to you and your preferred method. My party people, yes or no in the chat box. Are we starting to understand the 2 phases of word problems here a little better? Hey, there we go. Even if it's a kinda, I will take that. That's a very good sign. Very good sign. Now, to answer the question from earlier, are we going to continue doing harder and harder questions? Absolutely. Tomorrow's class, the next lesson, if you're watching the recording, is going to feature more and more difficult questions within the realm of proportions. Those 2 different types of questions are going to be part to total questions and triple ratios, both of which you should be ready to do. So with that, I want to write out just one more way that this could have been set up. If you wanted to set this up a different way, we could have also done this. Here on the bottom right side, check it out. We could have done the comparison of blue to blue, 18 over 3, then compare red to red, x over 5. Because the comparison is going to be this. Blue compared to red on the right, blue compared to red on the right. So the comparison is blue to red, left to right, blue to red, left to right. So you could have gone ahead and set it up this way as well. You'll still get the same exact answer. Hey, Jacob, right on. I'm glad you're understanding it even better now. So with that, I'll give us a chance here to go ahead and take a screenshot, finish writing up anything you need to. But if you're ready to move forward to the next question, just give us a ready in the chat box and we'll get the next one going. Also, congratulations, iPhone. I see there in the chat box you came in to let us know that you got back and you passed. Let's go. Congratulations. I saw all the party people there. Congratulated you already. Hopefully I'm not too late, but congratulations. Thanks for sharing. Perfect. Looks like we're ready to go. All right, moving forward here in 3, 2, 1. The first thing I want y'all to tell me here in the chat box is, what is the goal of the question? Read the question first here. 5 seconds. What is the goal of the question? What is the goal? Yeah, read the question first. What is the goal? Yep, we are trying to find the number of male players. Correct. The number of male players. Yeah, read that question. I got you. So we see here that it says, if there are 28 female players, how many male players should there be? Right on. So if there are 28 female players, how many males? So let's write this down here, everybody. I'm going to say that we have blank male players. And everybody, how many female players did they give us? They gave us 28 female, correct? 28 females present. Sounds good. All right. So if there are 28 female, how many male players? That's the information I extrapolated or took away from that question sentence. Is everybody understanding where I'm coming from when I wrote these two pieces of information down? And are we ready to start breaking down the rest of the information? Sweet. Sounds good. So here's what I'm going to do. I'm going to purposefully tell you, on purpose, that I am going to make a mistake. Maybe not right now, maybe not in the next step, but at some point, I am going to make a mistake. I want to see if you can catch my mistake. Now, before we learn how to catch the mistake, pop quiz. What is the main idea for proportion word problems? What is that main idea? All the words given. Yes, compare the same things in the same way. Everybody go ahead and hit me in the chat box. Everybody write it down. Trust me, I am just trying to do you a favor. It might feel annoying doing it over and over again, but you know, that's what practice is. Repetition. Compare the same things in the same way. Perfect. All right. Now, let's go ahead here and just take the next step here. So, in a local soccer tournament, the ratio of female players to male players is 4-7. So, I remember from the last problem, I was listening to myself. I said that the order of the ratio matters. Everybody, yes or no? Is that true? So if they say the ratio of female to male, female was first, so the 4 is female. Male is second, so male is 7. Yeah, exactly. So that's good. That's all correct. Perfect. Let's write that down. I'm going to write that down here in blue. I'm going to say the ratio of female to male. Female was 4, and then 7 was for males, so 7 males. So I wrote that down correctly. Perfect. We're good. Now, everybody, take a look. We have 1, 2, 3, 4 things that we could write in a proportion. So we have 3 of the 4 pieces. So I can write down X for that variable, no problem. And now what I'm going to do is write out my proportion by comparing everything. So I'm going to do male to female over here. So I'm going to do X compared to 28. Let me write this down over here. X compared to 28. And watch how I'm going to do it so y'all know that I'm doing it correctly, right? I'm going to go ahead and do right here, this to this, and this to this. So over here on the right side, I'm going to do 4-7. Everybody, are we good? Are we good to solve this? Wow, I've never had such a group of people so excited to tell me that I'm wrong. I don't know if I should cry or just end this. I'm kidding. Y'all are good. That was a good catch, everybody. I'm glad that mostly every single person here realized, yo, this is wrong. This is absolutely wrong. Now, why is this wrong, everybody? Y'all said the wrong order. Y'all said the wrong order. Now, let's go ahead and prove that this is indeed the wrong order. This is how you can easily do it, everybody. Watch this. Everybody, the X represents what? The X represents what idea? Yes, it represents male. So I'm going to go ahead and just use, let's just go ahead and say red for male, and then I'll do blue for female just to keep it simple, okay? So we have X is males, so I'll do M for right there for males. Then 28 over here, that's females, so let me go ahead and write F for females. Now, everybody, let's go ahead and check this on the right side. Everybody, the 4 that we wrote down over here represents what? Correct, represents females. So let's go ahead and write the F right there up top. And then the 7 over here is represented by what? Correct, represented by males. So I'll write that down right over here. So everybody, take a look. Take a real close, hard look. Yes, we are comparing the same things. We have males and females on the left side, males and females on the right side. So yeah, we are comparing the same things. However, are we doing it in the same way? Correct. No, we are not. We are not doing it in the same way. Just use your eyes. Take a look. We have males up top, female on the bottom. Male to female is the comparison on the left. On the right, it's female to male. That is not the same comparison in the same way. That's how I know that if I solved this proportion, I would automatically be wrong. Automatically. Who here sees what I'm saying? Who here understands this to make sense? Like, yeah, this is not the same order of comparison, so this would be wrong. There we go. Amazing. So we have two options, really. Two simple options. We can either, let me just put male again. We can either flip, so swap the top and the bottom over here to put males up top, females on the bottom. Or we can just swap this to make sure that we have females up top and males on the bottom. Either way is fine, everybody. Either way is fine. Here's what I'm going to do. Just keep it simple. I'll move this on the bottom, this up top. So that way we are comparing in the proper order, one of the proper orders. There's other ways we could do it, but here now we have consistency. We have males up top, females on the bottom. Now we are comparing the same things in the same way. Who here sees that now? Males to females, males to females. Now we're good. So that's what the main idea means, everybody. Compare the same things in the same way. That's how that looks. And now that we're here, what are the options? We can cross, multiply, and divide. We can go ahead and compare. We can try to simplify. We have all these different options. So let's just go ahead and go with the very straightforward, essentially basic way, and let's get it done. Let me erase these because, again, that was a false comparison. And I'll also change the order in the comparison over here. So it's the same way. Males, females. Now we know we're good. And that's how I swapped it over here because I swapped it over here so I can show you the right way. Yeah, now we're good. So from here, let's cross multiply and divide, and we're good. Oh, Vanessa, let me just answer that question. Vanessa asked, hey, shouldn't the 28 be up top? Again, we could absolutely do it that way. This is a correct setup. And also this over here, if we did 28 over x equals 4 over 7, this is also correct. That is also correct. Either one works, Vanessa and everybody else. Either one works because here on the bottom one, we are comparing females on the top to males on the bottom. So either way would be correct. Yeah. Sweet. I saw a couple of us had questions on that. I really want to make sure that you feel confident through and through. I got you. So there we are. I'm just going to get rid of this. I'm going to let you, let me just move this off to the side actually. One moment. There we go. Perfect. All right. So now let's go ahead and solve. We can cross multiply and divide. But if we notice, just very briefly, with the comparison method, to get to the x, we can try to go from bottom to top, which 4 going to 7, not that easy. Or we can go from right to left. 4 times 7 is 28. 7 times 7, that's 49. And we can get to the answer super quick if we noticed the convenience. Even if we didn't, you're good. Because here, we can just cross multiply and divide and be done. X times 4, that's 4x. And then 28 times 7, no worries, just a little bit of work, but we'll get that done. 28 times 7. 7 times 8 is 56. And then 2 times 7, that's going to be 14. 14 plus 5, that'll be 19. So we have 196. Lastly, everybody, to get to the correct answer, what do we do to both sides again? Yeah, we're going to divide by 4. Correct. So we'll divide by 4 on both sides. Cancels out on the left, giving us x equals, well, look at that. We got to do a little bit of long division here, right? Because this may not be obvious to the majority of us, and that's okay. So 196. 4 goes into 19. That'll be 4 times. Got 3 left over. Drop the 6. 4 goes into 36. 9 times. And that's a clean division, no remainder. So that would be indeed 49. And there we are. Confirm that it's the correct answer. And we are good. And yeah, did anybody here set it up the other way? Did anybody here set it up this way and still get the same correct answer? Yeah, there you go. That's how you know you can pat yourself on the back, knowing that as long as you are comparing the same things in the same way, the more you know, PBS. The more you compare the same things in the same way, the more confident you will be. So there's always, again, a multitude of ways of setting it up. And as long as you compare the same things in the same way, you are good. So with that, although we are a couple of problems away from doing the official timed practice, would you like to try some timed practice now? Would you like to try the next problem under a timer? Ooh, I like the tenacity here. I like the willingness to try. All right, sounds good. So let me go ahead here and get the timer up. And we're going to give it a 2-minute timer here with a buffer of 10 seconds for any lag for anybody. Here's the timer. And here we go. 3, 2, and 1. Give it a shot. And as always, respect your classmates. Do not share the answer until the time is up. Just type ready when you're ready, and we'll reveal the answer when the time comes. But do not reveal the answer yet. And we're looking at our final 10 seconds. Feel free to put those answers in. Put a question mark next to your answer if you might be taking a guess. And time is up, everybody. Go ahead. Put those answers in. Put it in confidently. I got you. So let me go ahead here. Remove that timer right there. And let's give it a shot, everybody. Let's give it a shot. So first things first, read that question right here. Here's the whole question sentence. Let's write it down. So here it says, if there are 15 banana pieces used, how many strawberry pieces are needed? So everybody, what is it that we're looking for? Is it bananas or strawberries? What are we looking for? Yeah, we're looking for the number of strawberry pieces. We got to be very clear here, because the moment that you start, I'm not going to call it getting lazy, because sometimes you get fatigued, right? Sometimes your brain is a little drained and you might overlook some details. We're human. It happens. But you have got to focus as best you can. If there's any part of the question that you focus the main part of your attention on, it's the question. It's the goal. We want to know how many strawberry pieces. We have 15 banana pieces. Let me write that down. We have 15 banana pieces, and we are looking for blank strawberry pieces. All right, everybody, is that correctly interpreted from the question sentence? We're looking for the number of strawberry. We have 15 banana. Good. That is the way. Now let me highlight that. 15 banana pieces. How many strawberry pieces? There we go. Now let's take a look at the given information. It says here, in a smoothie blend, the ratio of banana pieces to strawberry pieces is 3:4. Now I'm going to write that ratio out. 3 first, and then the 4 second. Let me write that out right over here. Let's go ahead and just keep using black. So I'll write 3 and then 4. Now, don't go off of this. Do not go off of this, everybody. Go off of the order in which it is stated. Which idea, which fruit represents the 3? Which one? Correct. Bananas. Notice how it's read. It is read as banana pieces first, strawberry pieces second. The ratio of banana to strawberry, banana first, 3, strawberry is second, 4. So the 3 represents bananas, 4 represents strawberry. And that's convenient because it's already laid out in the same order as the top. It's already laid out. So it's convenient. But one of the biggest mistakes that people make, and y'all tell me if this has been you in the past, where, oh, the first number must be the first number that I wrote down before, The second number must represent the second number I wrote down before. You make those assumptions, and then somewhere along the lines, you get the wrong answer. Who's been there before? Yeah, very common mistake. Very common mistake. And that's why I want to make sure that, we play these little games and try to find my mistakes. I want to make sure we keep it light because it's so important that we pay attention to detail. So with that, let's finish things up here. We know that we have the proper values associated with the proper ideas. And we know that we have the same comparisons now, bananas to strawberries, bananas to strawberries. So now we're good to go. We're confident that we can set up our proportion, and we're done. So here's my proportion setup. Fraction equals fraction. I'll go ahead and compare it like this. I'll compare bananas up top and strawberries on the bottom. So that means banana 15, strawberry X. Banana 3, strawberry 4. Everybody, is my setup appropriate? Is it done correctly? Sweet. Sounds good. So now let's go ahead and finish the problem off. We have options. We can cross multiply and divide, or we can try to simplify or compare. Either way works. Don't stress yourself too much trying to find that comparison. If you don't see it, that's fine. That's fine. We can just go ahead and cross multiply and divide. So confirming, yes, this is one of the ways to set it up. You can also set it up as 15 over 3 equals x over 4. That is also another correct setup in case your setup looks different. Yeah, gotcha, Grace. That's probably what I was calling out right there. I got you. But here we go. Cross multiply 3 times x. That's going to be 3x. 15 times 4. Everybody, what's 15 times 4? Who knows what that is? Correct. Appreciate you, Giovanni. That's going to be 60. 15 times 4 equals 60. So now we have 3x equals 60. And now what we'll do is we'll divide both sides by 3, and then we're done. That is the conclusion of that problem. Divide by 3 on both sides. Cancels out on the left, leaving me with x equals 20. And there we go. The correct answer here is D, 20. 20 strawberry pieces. Another way that we can do this, like I said before, is with the comparison technique. So what we will do there will be like this. We can go ahead and try to get to the x some way, somehow. The two ways that we can try to do that are going from top to bottom or from right to left. Both ways could work. But when I try to look at the top to bottom on the right side, not very convenient, not very convenient. However, if I take a look at the horizontal, going from right to left, everybody, what's the comparison? Again, give me the operation and the number. What's the comparison from 3 to 15? What's that comparison going to be? Yeah, the operation is multiplication, and it's going to be by 5. Going from 3 to 15, that's a relationship of times 5. Everybody, you know me. I'm a terrible mathematician. You all know that already. What's 3 times 5? 15. What's 4 times 5? 20. And that's how we get the answer. 20. And we are done. So again, either way, do we understand now better than before that there are 2 phases to word problems, everybody? 2 phases. Number 1 is the setup, comparing the same things in the same way. And then number 2 is the actual calculation, the method that you choose to calculate with, whether it's cross multiplication and division, whether it's simplification, whether it's convenient comparisons. It's really going to be up to you. But if all else fails, pop quiz. If all else fails, if you can't simplify and you can't see a convenient situation, what do we always resort to? Yeah, we always resort to cross multiplication and division. Always resort to that. Don't waste time if you don't see it. Get right to it. So in the next lesson, my party people, we here currently have set the stage with those fundamentals. Our foundations are set here with proportions. Now we're ready to handle those big bad questions that I know y'all have seen on the test, where we've done not part to part, not banana to strawberry, but perhaps banana to total, perhaps banana to strawberry to peach. Yeah, part to total questions and triple ratio questions, those can be nightmares, but you've set the stage here tonight with part 1, because in the next lesson, we can kick it into high gear and make those tough questions feel like cake. Who's ready for that?